Right now, 80% of in-house enterprise AI projects fail. Teams build a promising prototype, assume the hard work is over, and then watch the system fracture under the pressure of real-world deployment. This diagram shows the default starting point for most teams, known as naive RAG. You take a vector database, connect it to a large language model, and type in a query. In a controlled test, it works, but in production, this simple pipeline immediately breaks down. The model hallucinates answers, leaks sensitive internal documents, and falls victim to prompt hijacking. To fix this, we have to move toward the modular RAG architecture shown on the right. This requires building a strict, heavily engineered environment around the model. We achieve this through aggressive data curation, automated refresh pipelines, and multi-layered security. Surviving the transition from prototype to production means shifting your attention away from the language model itself. The real work is building the rigorous infrastructure that surrounds it. Step 1 is data curation. The old programming rule of garbage in, garbage out is the defining law of retrieval-augmented generation. A common error is dumping an entire corporate history, every old Slack message and deprecated wiki page, into a single database. Instead, we isolate primary sources, like API references, as the core context. For everything else, we apply strict filtering, enforcing recency thresholds and author verification. Finally, we split the surviving data into completely isolated vector stores, one public, one private. By aggressively filtering inputs and physically segregating the databases, we remove the system's ability to pull deprecated or contradictory information. The model can only surface what we have explicitly verified. Step 2 addresses data decay. If you upload your knowledge base once and leave it static, your AI will immediately begin giving outdated answers and missing critical product updates. To prevent this, we implement delta processing. Scheduled cron jobs monitor primary sources. When a document updates, the system extracts modified text, validates formatting, and replaces that specific outdated chunk in the database, leaving surrounding data completely untouched. Delta processing keeps your compute costs exceptionally low, while ensuring your RAG architecture answers questions accurately based on features shipped just minutes prior. Step 3 secures the system. Once a public RAG endpoint goes live, it becomes a target. Malicious actors will attempt to swarm the endpoint with bot traffic or use prompt hijacking to manipulate the AI into revealing internal data. We build a 3-layer security gauntlet. First, an AI firewall normalizes incoming traffic. Second, a PII scrubber detects and masks sensitive strings like API keys. Third, role-based access controls explicitly verify user credentials before querying the private vector store. Security at the enterprise level is an active process. By placing this strict gauntlet ahead of the LLM, we resolve critical vulnerabilities before the model executes a single token. Once you establish strict data curation, automated refresh pipelines, and an active security gauntlet, your system graduates from a fragile proof of concept into enterprise infrastructure. The operational reality is a system that delivers precise answers from verified sources, updates its own knowledge base automatically, and actively deflects prompt attacks. With the foundation stable, we transition to the final lifecycle phase. Looking at the evaluation of RAG section on this ecosystem map, we implement frameworks to systematically track answer relevance and noise robustness. This gives us hard numerical data on hallucination rates over time. Deploying true enterprise AI requires letting go of the language model itself. The reliability of your final product depends entirely on the continuous measurement, optimization, and rigorous engineering of the data infrastructure feeding it.